Hey there, universe nerds. You've heard of black holes, those cosmic monsters that swallow everything, even light. But what if the universe has the opposite kind of object? Something that doesn't pull matter in, but spits it out. A place where nothing can enter, only escape. That's the wild idea behind white holes, the mirror twins of black holes. They're one of the strangest predictions of Einstein's equations, and if they exist, they could hold the key to the deepest mysteries in physics, even the birth of the universe itself. Let's rewind to where this idea comes from. When scientists first solved Einstein's equations for gravity, they discovered two solutions. One describing a black hole, a region where space-time curves inward infinitely, and another mathematically identical but reversed in time. That second solution described a region where matter cannot enter, only exit. A black hole devours, a white hole ejects. One is a cosmic drain, the other a cosmic fountain. They're two sides of the same mathematical coin. In a sense, you could think of a white hole as a movie of a black hole played backward. Imagine a singularity that throws out radiation, gas, and light instead of swallowing it. Nothing can go in. Even light trying to approach would be repelled. But here's the catch. If white holes really exist, they can't last long. The moment they emit matter, they lose mass and energy, quickly collapsing or fading away. That's why no one has ever seen one. At least, not yet. Some scientists think white holes might not exist in today's universe, but they could have existed in the past. In the moments after the Big Bang, when space-time itself was still forming, regions of extreme density could have behaved like white holes, expelling matter and energy into expanding space. In fact, some cosmologists wonder if the Big Bang itself could be the ultimate white hole, a single explosion of energy from which everything emerged. It's a poetic thought that our entire universe might be the inside-out version of a collapsed star from another realm. Another fascinating idea links white holes to black holes directly. In quantum physics, information isn't supposed to disappear, but black holes seem to destroy information, which has puzzled physicists for decades. The famous black hole information paradox. One possible solution? When a black hole evaporates through Hawking radiation, it could transform into a white hole at the very end of its life, releasing everything it ever swallowed in a final burst. In this scenario, black holes and white holes aren't opposites. They're different stages of the same life cycle. There's even a version of this idea tied to wormholes, tunnels connecting distant points in space-time. Some theories suggest a black hole could be connected to a white hole somewhere else, forming a passage between regions of the universe, or even between universes. Matter falling into the black hole would reappear through the white hole's exit. It's pure speculation, but it's mathematically consistent. The catch? Such a wormhole would be violently unstable. The tiniest disturbance could cause it to collapse before anything or anyone could make it through. Still, it's one of those ideas that keeps physicists awake at night. You might wonder, if white holes exist, why haven't we found any? The truth is, we might have seen their signatures without realizing it. Some mysterious gamma-ray bursts, sudden, intense flashes of energy from deep space, have been suggested as possible white hole events. Others think certain fast radio bursts, those millisecond pulses of radio energy, could be relics of tiny white holes forming and evaporating instantly. There's no solid proof yet, but the idea keeps popping up whenever the universe does something we can't quite explain. White holes also challenge our understanding of time itself. Black holes represent regions where time effectively stops. Once you cross the event horizon, your fate is sealed. White holes, on the other hand, reverse the arrow of time. They represent regions where time moves away from the singularity instead of toward it. If black holes are cosmic memories, trapping everything that ever happened, white holes are cosmic beginnings, events that only move forward, never backward. It's a strange symmetry. One side consumes, the other creates. Of course, most physicists see white holes as purely theoretical. There's no direct evidence they exist, and their stability is questionable. Still, they're valuable because they push us to think about what's possible within Einstein's equations and where those equations might break down. They remind us that the universe is full of symmetries, dualities, and mysteries that aren't always visible. Sometimes understanding what can't exist teaches us just as much as what does. So what are white holes? They're the mirror image of black holes, mathematical opposites, theoretical fountains of creation instead of destruction. Whether they exist or not, they represent the universe's love of symmetry, a cosmic reminder that even the darkest things might have a light side. Maybe white holes are rare relics of the Big Bang. Maybe they're the final flash of dying black holes. Or maybe they're waiting in the math, whispering that the story of space-time is far from over.